this webinar, this CAD Talk and Syteline User Network webinar featuring the fine gentleman here before you from PBC Linear. Thanks, Jonathan and Ethan, for joining. I'm going to go ahead and share my screen real quick so we have the slide deck to go off of, and just give me a A-OK that you guys can see my screen. Let me get to the right slide there. Can everyone see this? Jonathan, Ethan, can you see the screen? Yep. Great. But yes, thanks again, everyone, for joining. While we wanted to wait just a couple more seconds while people join in, but a couple of business items. If you have any questions along the way, feel free to pop those in the chat or in the Q&A section. We'll be sure to get those. We'll also have a Q&A section at the end for you to submit those questions for Ethan and Jonathan or myself to answer. Yes, thanks again, everyone, for joining, and we can go ahead and hop into the discussion. So Jonathan and Ethan, if you don't mind going ahead and introducing yourself and telling us a little bit about PBC Linear. Jonathan, we'll start with you.
Sure. My name is Jonathan Schroeder. I am the Chief Technical and Strategy Officer for PBC Linear. I'm in charge of IT, new product development, long-term strategy, and international relationships for the business.
All right. I'm Ethan Kinney, and I'm the Software Engineering Manager here at PBC. I'm responsible for integrations between all of our different software systems, our ERP systems, back-end CAD systems, front-end CRM systems. So getting those implemented and integrated and automated to the best of my abilities.
Great, thanks for those quick intros. I wanted to briefly hop back to this agenda. So we'll cover PBC Linear's journey from essentially a 2 to 3 week lead time from their designs being finished to their production starting on the shop floor. And they've been able to build a really robust system of technology that has helped cut that 2 to 3 week lead time down to about 10 minutes. And we'll cover as much as we can in the hour that we have, but in the meantime, we'll sort of flow this progression of their vision, the challenges that they faced, the setup of their model-based enterprise, and the solutions that they found worked for them along the way, and the results that they see now. So moving sort of back into PBC Linear's business model, Jonathan, if you wouldn't mind sharing just a little bit about what PBC Linear does, what you guys make, things like that, that'd be great.
Yeah, sure. PBC Linear makes primarily plane bearings, but we make linear motion bearings, linear guides, precision rolled and ground screws, linear actuators. Then we also do some contract assembly. We assemble a large format 3D printer. We assemble an automatic robot feeding system. We've done other contract assembly for some of our customers as well. And if looking at that, I'll just continue with the rest of the slide for you too. From an application standpoint of who we serve, our bearings and linear motion products are found anywhere from deep submersibles in the ocean. NASA has launched our bearings into outer space. You find our bearings in foundries, so very dirty applications, and in clean rooms, very clean applications, and even some operating rooms. For those of you that have kids and been to Disney, and you've seen the It's a Small World ride, some of the little animatronics there have our bearings inside of them. We awesome. Ship, and then globally, we are our primary locations in Northern Illinois. We have a wholly owned subsidiary in Germany, a joint venture in China, and we ship to over 100 countries around the world.
It's very, very cool. And something that I never would have expected to be in so many places in your hand in so many different areas of the world. And it's really cool to see that. So you and I talked a few months ago when we did a video together about this story, and you mentioned a 20-year dream, this idea that 20 years ago, you sort of had a eureka moment that something was wrong and there must be a better way. And so if you wouldn't mind sort of painting a picture where your organization was 20 years ago and where you saw it going in the future?
Yeah, this all started. I had to do a project where I had to design a 3-axis gantry system. So it's basically a Cartesian robot, X, Y, Z travel, fairly simple from a optics standpoint of what it was doing. It was just doing some simple pick and place, and it wasn't even a super demanding application. It was for a trade show demo that we were doing in partnership with a servo motor manufacturer, and it took me over 40 hours to design that system. By the time I did the mathematical calculations for it, did all the force calculations, all the acceleration, all that kind of stuff, all the force vectors, all of that, and then went and looked through our catalogs, looked through the catalogs for the coupling manufacturer, the gearbox manufacturer, the servo motor manufacturer, the cable carrier manufacturer, the sensor manufacturers, lined everything up. It took me a little bit over 40 hours to do the design, and I'm in the linear bearing industry. I already knew what all the formulas were. I didn't have to look them up. And I'm like, this is stupid. This shouldn't take this long. I should be able to go to some kind of a configurator and like be able to instantly pick all this stuff out. And that's kind of where the dream really started. If I were to go back and look at that from a customer's perspective, you would have, once you did that 40 hours worth of design, then you would have a whole bunch of time spent reaching out and getting quotes from different companies. You would then place an order with them, and then typical lead time for actuators at that time, it was like 4 to 12 weeks for products. So, your whole process there could have been a 4-month project to build something that should be relatively simple to design and relatively simple to get.
So a lot of headaches all around, both on the design, manufacturing, and the customer side of things, it seems.
Absolutely.
Cool. Or I guess not cool, but later it gets cool, I should say.
Right.
So moving a bit in, taking a step in the right direction, Ethan, you and I talked about the importance of developing a model-based enterprise, developing a single source of truth, and how vital that was as the initial step toward accomplishing this vision of a customer coming to the website, configuring a product, and then it's immediately started to manufacture. So can you discuss a little bit about the importance of a model-based enterprise and how you got there?
So when I first came onto the company, I was just hired on as a SolidWorks guru. And then I got word of this vision that Jonathan and his father had of what they wanted the automations to look like. When we started looking at different configurators out of there, some of the issues became apparent where you were essentially creating another version of your product for consumer level, but you still had to create a version of your product internally. We didn't want to do that. We wanted to create a singular version of the truth, and that's accomplished through model-based enterprise. So the idea there is you put all of your details into your model, and then your drawing, your inspection sheets, your ERP, your bounds and routings are all driven from that same model, as opposed to having a model which is disconnected from your drawing, which is disconnected from your ERP system, and you have to manually modify and maintain all 3 of those data sources or more for every additional data source you add on to there. So from the get-go, we wanted to design a system that creates a manufactured component, assembly, the parts, all of it, and goes through the entire process to where at the end, it doesn't matter if it's the customer looking at a de-featured model, or if it's the engineer looking at the model, or the CNC programmer looking at the model. They all have the same source of truth there. And then especially when it comes to the ERP system, so that way when the engineer is working on the model and the drawings, they can just sync that up with the ERP system and not have to go spend twice as much of their time going into that ERP system to update routings, bill of materials, quantities, all of that, when they've already done it on the CAD design side. So we wanted to walk through that entire process where it is the same thing going all the way through, one, to eliminate the redundancy in everybody having to do multiple levels of work, but two, reduce the errors that are going through there. Because anytime you add a redundancy of information entering, you're increasing the risk of entering bad data. And every time you do that, it's just a greater and greater risk. And we know as humans, at some point, bad data is going to get in there. It's just to what extent is the bad data going to propagate through your system. So that's where we started. We wanted to find a single source of truth. So we actually started our configurator process by looking at making configurators that were designed for manufacturability. So they weren't designed initially just to look good for the end consumer, but to make them look like they came from an actual engineer when they hit the shop floor. We wanted an operator at the machine to look at the drawing and go, I don't know if this came from the software or if it came from a person. So that was the benchmark that was set for us going out. We had to have it to where as it goes through all these processes, it looks like a professional engineer did all the work and got them all the information.
And we do operational prints in our business. So whether a finished good product has 1 step or 15, we do a process print for every step in the operation, not just a finished dimensional print, which sometimes what a lot of companies do. So that makes it a little bit more, actually in some cases a lot more complicated for this project overall. One other thing I will mention, because it's relevant for our business, because we make linear motion products, when engineers download our CAD models, they expect them to move. And it's a big challenge to design a model that, no matter what CAD system the customer uses, right? Because we design in SolidWorks, and those of us that are in the engineering industry know that SolidWorks doesn't always play nicely with CATIA and Creo and all the other CAD systems that are, and Autodesk, all the other CAD systems are out there. So you have to do a neutral model, and finding a way to realign that neutral model to allow it to move back and forth is a bit challenging, while also making sure that we don't give away all of our IP of the magic of how PVC makes our products work. So it's a bit more of a challenge than Ethan initially said, and Ethan gets a lot more credit than he was giving himself credit for there.
Right. Well, got to give credit where credit is due. Ethan, you and I also talked a lot about this journey, sort of laying the foundation of what it took to sort of get everyone on the same page for this, moving toward this model-based enterprise. And it seems like from what you just said, a major first step was finding the right configurator, moving forward with the right configurator. But you also mentioned several other steps, and I included some of those in this slide here. But if you wouldn't mind going into a bit more detail of what laying the foundation for moving toward a model-based enterprise looked for you, and the benefits that you found along the way.
Yeah, so probably even before the standardizing data would be setting expectations of what we want this whole system to do. Because if you don't set the proper expectations as to what the output needs to be, you're going to set yourself up for failure. So the benefit I had coming on board was the expectation was already laid out over the previous 20 years of different attempts at trying to build out a full configuration system. So I had a good running start of where to go from there. The first challenge I ran into, though, was actually standardizing our data. So we talk about the configurator to build all of this stuff. Well, that relies on some data tables that have all of our manufacturing tolerances, our dimensions, operations, all of that information. When I first came on board, that was spread across probably 5,000 different drawings for the same product line. So the first giant lift of work was taking all of that information, standardizing it into data tables, but then coming up with the rules that link the different operations and the steps together So it's not just random numbers on the spreadsheet, but it's actually rules for why does this dimension change to this? Well, it's because we removed this much material in the operation, which is either a fixed amount or a percentage or a formula derived amount. The benefit is when you go through that whole process, it does take a while. It allows you to look at the manufacturability of your products and look at the different issues throughout the different steps and take care of those issues. So on some product lines or some dimensional sizes of our bearings, we would have issues, but we wouldn't have them on other sizes. Well, it's because the operations were doing different amounts of material. Once we standardized our formulas and all of the information there, everything started flowing through a lot easier. It also makes it a lot easier when an operator comes to you saying, hey, I want to open up the tolerances on this operation because I'm having troubles. You can say, all right, let's look at all the rules. So we're not going to open up just on this one part. We're going to change it on everything. And it either is like, yeah, that makes perfect sense, or the pushback that you give to the operator helps them to understand why things are set the way they are. It's not just what they're doing there, but how it affects everything else going down the stream. So that was the big lift, is getting all the standardized data in there. And I would be lying if I didn't say that took quite a lot of time to go through. I mean, it took a while to pull all the data together, but to actually sit down with everybody and come to an agreement and understanding of this is why the product is manufactured the way it is. That took a while too. So, and that, yeah, leads into that second point there, the company-wide agreement. These are manufacturing processes. So once you have everything written down, it becomes a rule set or a procedure as opposed to a drawing. A drawing is very easy to redline. We dealt with that a lot in the early stages of drawings getting redlined on the shop floor just so they could get manufacturing done. And getting that to flow all the way back to the start process and get fixed was difficult. But after getting all of the data tables in place, that whole redlining almost went away entirely. Because at this point, all of the inventions are agreed upon by everybody and the operators as to why we're doing what we're doing. So it takes away that that want to push back and change things just to make the manufacturing easier. And that talks about the formula-driven control there of why we have the formulas. So it's not only the dimensional formulas that we have in there, but it's also the rules-based formulas if we add certain features when certain other features are selected by the customer. For instance, if we're doing turn journals on some of our screws, we have to have center point drills on them to maintain the tolerances while we're grinding the journals. Well, those features get added in only in specific cases. So adding all of those rules into it and taking it away from the tribal knowledge database of all the engineers and the operators' brains out there and actually putting it into a system that everybody can see and understand is a huge step, because then it takes the burden of design away from individuals and puts it on the system. So if there's an issue, the burden isn't on, well, the engineer did it wrong. The burden's on, well, we need to fix the process. So it gets more people behind wanting to fix the root cause as opposed to just blaming somebody else, which helps a lot in pushing the company forward. And so going through all of this.
Sorry, before you move on, there's one thing I wanted to ask about there. Something that I hear a lot of people in the manufacturing space talking about right now is the large group of people who work in manufacturing who are on the cusp of aging out and retiring, and there's a knowledge skill gap between those folks and the people who are coming in and who are working in or who are being trained. How do you feel like the system that you have in place is so that you talked about this tribal knowledge? Do you think your process is in a place where a relatively new person on the design or the manufacturing side could come in and relatively quickly pick up on the tribal knowledge and how things run and things like that?
Yep. So that was another benefit of it. It was a requirement to get the systems in place, but when you bring on new engineers, they don't go through the painful process of doing something they think's right and then getting chastised because it was actually a wrong process, because we had figured out how to do it before, but we didn't document it somewhere, or we didn't have the rules somewhere for them to quickly reference, or they didn't know to talk to the right person. By having it all systematically laid out, it just flows through the system. You can bring on somebody and get them onboarded within a couple of weeks and running what we would consider standard products or new product development fairly easily.
That seems like a huge help.
It is, and I think this is a pretty common problem that a lot of older, more established companies with mature products face, right? Because we can see this, right? Our standard simplicity bearing here seems like a pretty simple, easy product to manufacture. It's only got a couple of components to it, but this bearing was originally designed in the early 1980s. That was, for us, that was 5 factories ago. That was several generations of manufacturing equipment ago. That was several generations of employees ago. And some of the prints for this, before we did the configurator, some of our prints, actually the original creation date on them was 1980 something. But again, this little simple bearing, there's actually over 125,000 different permutations of this after you take into account 3 different measurement systems, the inch, the European metric, the JIS metric. You've got 25 different diameter sizes available, a couple of different options for seal configurations, a couple of different options for internal lubrication, different bearing shell materials, different liner options. So you get all these possible permutations. And of course, over time, some of them get designed here for the first time, although they follow standard rules. The original bearings were designed in 1982-83 timeframe, and then there's it doesn't happen as much anymore, but every once in a while, even the new configuration might come out in 2025, and so we have to make sure that we follow all that process through, and our prints look the same, but the original process is different. So we've had ECNs over time on a lot of these different bearings too, and that's the challenge I think that PVC had, and a lot of other companies with older mature products, of course, have as well.
That makes sense. Sorry, I interrupted you, Ethan, earlier, but were you moving on to past the formula-driven control?
So into the actual implementation phase, once we got all the data and we got the models, building the configurators was relatively easy, so to speak. The implementation actually took longer because we were changing processes through our entire shop floor. So we had to work with about 100 different operators to explain and bring them up to speed on this is a new process that we're coming up with. We're not doing red lines anymore. If you have issues, you got to bring it back. We had to have engineering fully on board with it to help push this through, because as issues came up, the operators would see the engineers, and the engineers would have to go through the database, understand what's going on with the tolerances or the dimensions, and make the appropriate changes there, but also understand how that affects everything downstream and across different sizes too. So it made the speed of fixing one issue take a little bit longer, but the results of fixing an issue would actually improve the entire product line.
Got you. Can you speak a little bit about why you chose Infor CPQ?
Yeah. So Infor CPQ allowed us to extend the back-end functionality of the software. So most configure price quote packages, most CPQ packages come out with just basic CAD support or a basic front-end system for generating CAD. We wanted, again, per the expectations and the requirements, to create a fully driven, manufacturable component. So to be able to do that, we had to be able to tie in custom processes, either creating custom macros in SolidWorks or custom external programs to do additional calculations or feature manipulation, we had to be able to extend it to our needs. So that's why we ended up on Infor CPQ. At the time, there were really only 2 or 3 big contenders, and Infor CPQ, at the time it was called Infor PCM, so project, I don't even remember what the acronym was at the time, but it was really the front runner for us. And even today, when I glance around at some of the different platforms out there, I really still don't see a better platform to use than Infor CPQ.
That's great. Yeah, just put a reminder in the chat for everyone. But if anyone has any questions, feel free to put those in the Q&A section, and we'll be sure to get to as many as we can throughout the course of the webinar, or at the end we blocked out some time to make sure we hit some questions. Moving on, we discussed when I was on site in May the fact that things were working. You were getting your designs. The CPQ was, operating as it should. The production line was operating as it should. Jonathan, if you don't mind speaking to this a little bit, that before, I guess, spoiler alert, you later implemented CADTALK that solved this problem. But what was the problem that you were facing between the CPQ and the designs being created and the shop floor actually manufacturing them?
Well, actually, if you don't mind, I'll jump into this one.
Yeah, sure.
So Infor CPQ does come with native functionality to integrate into ERP systems. So we use Infor Syteline. It did have that functionality, but going back to the model-based enterprise, the issue was you'd be forking yourself in the road there. You'd have your configurator, which pushes information to your CAD model and then pushes information up to your ERP system. That's fine if everything 100% runs through your configurator, and that's it. However, we do a lot of customs or new product releases where we will take a standard product, do some slight modifications to it, and sell that as a custom component to customers. Well, if we have the configurator pushing information up there, but then we have a generic CAD model, the engineer still then has to go into Syteline and do all the work for the new BOM, which introduces redundancy and potential errors. So we wanted the configurator to push everything into the CAD model, all the operations, everything, so that way when the engineer took it over, they could just make their edits to that. The issue is now we have that gap. All right, we've got everything on the CAD model. We've got everything in the drawing that's tied to the CAD model. And we've got everything on the inspection sheets tied to the CAD model. How do we get this up to the ERP system? Well, lo and behold, that's where CADTALK came into play. I actually got an email from Bob Schroeder, who's the CEO of the company, saying, hey, take a look at this package out here. And this is right as we were getting the first CAD models done and ready to go, and we realized, hey, we need to get this integrated up into there. We were starting to look at, well, I guess we could use these rules over here, and we'll just have to train the engineers how to do the modifications. But when we took a look at CADTALK, we realized, hey, we can keep SolidWorks as the source of truth, and we just sync it right up to the system, and we're good to go. So we jumped on board with CADTALK. We got that implemented right away. We trained the engineers how to start to use it. But then probably within a month or two, we were going, all right, how do we automate CADTALK too? So then we had another conversation with CADTALK, and your team came back and say, yeah, we have this autoloader functionality where your CAD model just goes into this queue. CADTALK spins up, it reads the model, finds everything in Syteline, and then creates your new items, your routings, your bombs, all of that information straight from your CAD model. So what's great about that is when we have the configurator running normally, it'll flow through the entire system. And then if an engineer comes into the play and says, hey, I need this, but they need to customize it, they can still run the configurator, get their model, make their tweaks, manually pull up CADTALK and push it into the system. And it saves them a tremendous amount of time. And it saves them from copying and pasting routings in the system, which was one of our sources of errors in the past, because we didn't want the engineers spending hours recreating everything. They would find something similar and copy and paste. Well, the issue is you didn't know how old that similar item is. That similar item could have been created the week before, but also created based on a previous item, based on a previous item. So you don't know how many errors were in that. So being able to implement CADTALK and link it all to the CAD model was huge.
And so you were finding that before going with the autoloader, that CADTALK was working exactly as it needed to be, and you were just becoming sort of a glorified button pusher at that point?
Yeah, the engineers were the glorified button pushers, because they would run through the CAD process, they would open up the model, or they'd open up CADTALK, import the model, hit sync, and they'd close it out, and they'd go on to the next one. So
Right.
we had to figure out, okay, how do we just take that button click out of it? Because they don't need to be doing that button click.
Got it. Jonathan, did you have anything to add in the in the gap in the process and how CADTALK filled it? If Ethan covered it all, that's fine as well. We can move on.
No, it's Ethan 99% got it. One thing I hear from plenty of other managers or executives when I speak with them at conferences and things is that glorified button pusher that you have is because people don't trust the configurator, right? And so what we have done to kind of overcome that, and this is a common hurdle I hear from lots of people, we set ourselves, whenever we create a new configurator, we set up a timeline that we say, okay, it's going to take, and it depends a little bit based on the complexity of the configuration and the model and the system and what we're doing. But we have the engineers do their initial check, and then once it releases to production, we only allow a certain amount of time or a certain number of configurations to go through, where the engineer still does that manual check to make sure that they don't find any issues. And once we go through that time period completely clean, then we're good. If we find an error, we just reset the timer and continue on. But at the end of the day, you know, this system, whether you use this system or some other system, data, you know, the cleanliness of data in, it represents the cleanliness of data out. If you put garbage in, you get garbage out. If you have clean information going in, you have clean information going out. So it's just that making sure that you have all those rules in place, that you catch all the little nuances. The other thing that we didn't mention earlier is, because our products can be used and abused, we have, you know, product specifications in our catalog that represent, you know, the extremely safe working limits of our products. But a lot of times, depending on the application, the product can actually be pushed beyond that. So we have our configurators, a lot of them set up so that the customer can only make choices that are within a very narrow window, comparatively speaking, a very narrow window that is extremely safe for an application. But our engineers or our application engineers can choose from a wider range of options, and to allow them to pick something that a customer might not be able to pick or to choose. But it's only after we verified application requirements.
Got you. So moving on a little bit, I want to make sure that we get to the reason that most people probably tuned in, that $100,000 saved in 24 hours. So I want to make sure we hit that. But Jonathan, you talked about this vision for a customer to come to your website to configure their desired item, and then a job packet prints on the floor. Can you just paint briefly a picture of what a customer experiences on your website, and then what happens on the back end for you guys?
Yeah, sure. So let's talk about the whole process from when a customer first visits us to when a job packet prints on ready for the shop floor. So obviously they purchase it in between, but when they go to the website, they are able to choose what product line that they want from us, and we have over 40 different product lines, 40 different product configurators available on our website. Virtually everything that we sell that's a standard product, you can go online and configure options for it. So you go to the configurator, you choose one of several billion possible permutations of products that we can manufacture. Now, and then they get the CAD model. Oftentimes, because it's a linear product, the first model an engineer tries doesn't exactly work, so they have to come back and they have to download a second model. Sometimes it's usually just a few inches longer, a few millimeters longer, to make sure that everything works and they have clearance for everything. Or, you know, some applications person on their side goes, oh, I want to throw an extra 10 pounds on that they didn't plan for. Then they have to go up a size in the product. That kind of stuff happens all the time. But after they choose what product they want, we generate a quotation for them. And here's where there's a little bit of fork in the road. The customer has a choice. They can either get a quotation and have it go through their internal process, or if they have a P card or a credit card, they can go ahead and place an order online immediately. So the configurator communicates with e-commerce on our website, and they can go ahead and place an order for that immediately online. If they place an order online, it would go into our ERP system, and that's where a lot of people that use the configurator pretty much stop their automation. And up until fairly recently, that's where we stopped our automation too. But for us, if a customer chooses one of the several billion permutations that we can possibly sell that hasn't been sold before, then goes through the very long and arduous process of us creating that part. So first thing that would happen, customer service would send an engineer a notice to production control that we just put in an order for something that doesn't exist yet. They put in an NR, new item release request, with engineering. It goes into the queue, and eventually engineering gets around to working on it. And when I say eventually, it could be anywhere from a couple of days to a couple of weeks. Engineering does what they need to do, which, depending on the complexity of the product, can take anywhere from, you know, an hour at the short end to about 2 days of time at the very long end, maybe even a little bit longer than that, depending on the complexity of the product. Then it goes into the typical ECN or NR release process, where it goes through from design engineering to manufacturing engineering to production to quality to purchasing, production control, to marketing, to accounting, you know, that whole process where all the different departments in the building have to touch it. And that whole process can take up to 4 to 6 weeks, depending on how backed up everybody is. And now we've automated all of that. So our magic button, thanks to Ethan and his team, is once a customer places an order online, they put in their credit card number. About 15-ish minutes later, depending on complexity and kind of server backlog time, a complete job packet prints out on the shop floor. So we have or in production control, we have all of the prints, all of the routings, all the inspection sheets, all of the BOMs, all the job tracking paperwork. We have, for some of our assemblies, they're indented BOMs. So you have the upper level assembly for the actuator, then you have a screw and a rail and an aluminum body or a bunch of other parts underneath that have to be manufactured. So whether you have one print or a complete indented BOM, all of that prints and is ready to hand out to the shop to get them started on the manufacturing process. And
That's awesome.
It's all done automatically without any human interaction from our front office.
And so from maybe, I don't know exactly how long you've been using this full system, but from maybe like 5 years ago, how long would a customer expect before they receive their item to now? How long do you think they could expect?
Yeah, so that, you know, once the customer places the order, this is where it got kind of ugly, right? Because we would, for a custom product, we also have something called a new release print, or a customer sign-off print, CSO, that the customer has to sign. So engineering would design the product, showing the customer interfacing dimensions. We would send it to the customer. They would sign off on it. Then it would go through the rest of the release process. Typically, again, depending on the complexity of the product and engineering's backlog, it would take anywhere from 1 to 4 weeks to get that customer sign-off print to the customer. Then there was a couple of weeks of additional time after that for all that other processing stuff, all that overhead that we don't like as managers. And then like typically 2 to 6 weeks for production time. So you're looking at anywhere from a couple of weeks to a couple of months for a customer to get their print or to get their part after they've ordered something from us. And now that's shrunk down to just the manufacturing time.
Okay. So the overhead has become almost negligible in comparison to what it once was.
Yeah, in general, again, depending on the complexity of the product and the product line and everything, we've eliminated typically 1 to 6 weeks out of the process from where we were 5 years ago. And then on the quoting side, the front end of things, we eliminated another, one day to 2 to 3 weeks from the quoting side as well.
So this next slide here, the time savings achieved is really just the internal process of the 2 to 3 weeks before was really just the internal process of the backlog time of engineering. It's not even accounting for all the rest of the stuff.
Yeah, it's a very, very conservative number here.
Okay.
Right. This is just the human capital, human overhead that we have eliminated. And, from a business standpoint, just kind of practically speaking, some of that has fallen to the bottom line. As we actually, through this, our business didn't actually eliminate any human positions from it. I mean, some businesses could. We chose not to. We chose, as time went on, to allow our people to focus on more value add applications within the business. So instead of doing repetitive, not fun work that no young engineer wants to do, we allow them to work on new product development, interface with customers, or work with manufacturing engineering. So we're allowed our people to move from one department to another. And then in some cases, as people naturally left the business through natural attrition, retirement, et cetera, we haven't necessarily replaced them.
Ethan, anything to add here on the sort of business or life impact on your engineers, manufacturers?
Yeah, so one of my good friends here, he's actually in the engineering department. And when I was first getting all of this set up, he took a glance at what I was working at, because he was in that day-to-day life of having to take something, copy and paste, and make edits, or do that simple new release that would take him several hours to do just on the drawing and CAD side, let alone the Q waiting side. And he went, yeah, I want to push this through. So he was kind of the guinea pig for me. He was willing to take it through on the engineering side and push prints out to the shop floor. And anytime that there were issues, he would take whatever the flack, he would condense down what the root of the issue was and bring that back to me for tweaking it and get it updated. So from the engineering standpoint, once they saw the power of what was going on and the time savings and the lack of redundancies that they would have to do in terms of documentation and clerical work, they were on board and they wanted to push that through, because they wanted to work on the fun stuff, the new products and the new features that we could develop here.
And maybe what is either of you can answer, what has been your experience with new hires coming into the system? Do you feel like they are excited to jump in because they're able to work on things that they want to work on, that they went to school for? Do you feel like they are sort of wowed by the level of sophistication and automation? What has been your experience with new hires coming in?
I would say a lot of the new hires that are coming in are different today than they were about a decade ago. About a decade ago, they were coming in, they were being trained on, here's all the processes and the systems that you have to understand in order to replicate these parts or to make these changes. So back then, they were taught a lot on systems and processes just to maintain what was existing. So PVC linear is 40 years old now. So at that point, it was 30 years old. Well, that's still 30 years of products that have been designed that are now out in the field that you have to continue to maintain for when customers come back and buy them, or just the breadth of the products at that time. Well, as you grow the amount of products that you have, maintaining those becomes a full-time job. So we had to make a leap somehow to get away from just having all these engineers just maintain. So take that approach back then versus now, where we bring on new engineers, not because, hey, we need somebody who can just maintain our backlog of our products, to no, we want new engineers here to help design the new generations of products that we're going to sell. And we're going to build them in such a way that, yeah, we can leverage the full power of the configurator. So once you're done designing, you don't have to sit there and just maintain it for the rest of your life. You can go on to the next product to develop itself at the company, and we're just going to add it into the system. So the system takes care of itself that way. It allows us to get more excited engineers that are looking at the new possibilities of what they can do versus effectively coming in and just maintaining the backlog of previous engineers' work.
Seems like a much better place to step into. Jonathan, did you have anything to add there?
Yeah, just from a company standpoint too, when you talk about engineers coming in and getting to work, you want them to get to work as quickly as possible to become efficient and be effective, right? All of that onboarding and learning is not necessarily truly a value add for the business. And if you don't have a central repository of all your knowledge, that 40 years of company history of tribal knowledge takes an awful long time for engineers to learn. And sometimes even like the nuanced, the littlest things of a few thousandths of an inch here or there are a big deal and make the difference between a product working and not working. So for us, shifting from this tribal knowledge where everybody had everything in their head to an engineering-based system where it's a rule-based system and all the rules are in spreadsheets and in rules within the software makes it a lot easier because engineers don't have to learn that. And then you also don't have the situation where somebody comes in, maybe doesn't fully understand all the repercussions of their thoughts or ideas. They think they're smarter than the 30 years of history that the company has, and they try to go and implement some change only to have it catastrophically fail. You have a better way to control all of that versus just letting people run with it, especially when you have permutations of products or product families. A lot of times we've seen people come in and some operator in the shop request an engineering change and they want it on the product they're manufacturing right now. So an engineering processes an EC, but they don't process an EC for all of the parent or children products or all the sibling products. And then you end up with very, very similar products being manufactured two different ways. And so you get that fork in the road that ultimately causes an issue down the road for us too. So all kinds of additional benefits out of this system.
So I think you give us a really good transition there to go into that 100,000 savings. I
was about to say the same thing.
Yep. So with this, what happened is that initial product line that we're talking about, that plain bearings, it's essentially bread and butter of the business, but it's 100,000 SKUs or 120,000 SKUs. At the time, we had roughly 15,000 SKUs in our system, but we had to make ECs and changes to this. These engineering changes would typically be weeks long because they would require almost all hands on deck to take care of them. So this could be hey, we brought in a new piece of equipment to speed up the manufacturability. Hey, that's great. We got to go through and we got to change effectively 15,000 drawings to apply for this new system. There's different ways you could do it. You could just say, hey, we'll update each drawing as it gets ordered, but you're effectively just kicking the can down the road for yourself there. And you're running into the issue of, was this print updated recently enough to take care of this? I'm sure anybody who's gone through SolidWorks on a drawing has seen the revision block when it starts to get out of control. Now imagine the revision block, but it's across 15,000 items, each one being revised individually. You don't know what's at what level, what EC has really taken care of what product. So by leveraging the configurator and CPQ, we were able to just do mass updates to all of the products. So we could take a couple thousand to 10,000 parts at a time. We would run them automatically through the configurator. It would generate the latest and greatest CAD models, prints, inspection sheets, all of that information, and then dump it into CADTALK, which would then upload all of that to the ERP system. So a process that would take several engineers several weeks to do, we could set up to run over a weekend and take care of and update everything to the latest routings. So one of the biggest benefits there is just taking away that redundancy of having to do it. I don't know about you, but anytime I have to do a redundant process, I get slower at it as I go. I don't get faster. It's just the boredom in me of having to repeat the same task makes it go slower. And the chances of me clicking on or copying something wrong increase dramatically the longer the task goes on. The beauty about computers and automation is they will just take the instructions and run with them. So the savings here, it's really on the effort involved in doing this and getting everything up to sync. We actually had a large EC like this not too long ago. We were changing one of the materials in our bearings. And again, it's every SKU has to be updated and every routing has to be updated in the system. So being able to run processes like this to just take care of everything is huge. And it saves us so much time.
Yeah, it's a great point. I want to make sure that we leave time for questions here at the end. We do have one question in the queue, but moving down a little bit, and I'll just make sure that everyone takes my word for it that these are not my words. But you guys told me that through implementing CADTALK and through the system that you have put in place with the CPQ and the steps in between, and that's what this question goes into that someone submitted. So we'll dive into this a little bit, but you guys been able to save what you estimate is at least $1 million a year through building this automation. And like we've touched on, this isn't just about saving dollars, but also putting engineers in place to not maintain, but push product lines forward, to create new product lines, to innovate, to create new business opportunities. So this is just a number on savings, really. It's not, I don't think, and maybe you disagree, I would say that this probably is not painting the full picture of the opportunity that it really affords you and your team, because this automation, sorry, go ahead.
Yeah, I would say, so over the last 12 months, we have created approximately 6,500 SKUs from the configurator. If you figure each of those SKUs takes about 4 hours of engineering time, about 4 hours of time through other departments to do the NR process, about 8 hours per SKU, that equates out to about 12 and a half full-time engineers, 12 and a half full-time employees in other departments, which equates to about $3 million total of annualized savings to us. So the number you saw in the $1 million, over time, we've been able to add about $1 million to our bottom line because over time, about 2/3 of the employees and the savings we get from the configurator, we come from either not replacing people as they naturally leave our business, but then we redirect other people. So the soft cost savings, if you will, is closer to $3 million. The hard cost for our business is closer to $1 million.
You also mentioned a opportunity. Not necessarily a cost, but opportunities there. We've been able to secure some business that we might not normally have been able to get just because we can turn around on information and print so much more quickly than our competitors, and we can get things into manufacturing queues so much quickly that we are winning on time alone. And in this day and age where people want it yesterday, we have to be able to respond as quick as possible to that. And especially with everything going on with tariffs and disruptions to supply chain, being able to deliver quickly to the customers has become extremely valuable to the customer base.
Right. And in from a not really a business to business transaction, people have in mind this idea that Amazon can get me a package in 2 days for what I ordered. So that idea of instantly I want what I ordered, it's pervasive in society now, and businesses are having to deal with that as well. I want to make sure that we get to some questions, so I'll leave this lessons learned slide up. But there is a question in the queue. Does the complete automation from order to shop floor, the 2 to 3 weeks to 10 minutes, all happen between CADTALK and the ERP, or are you also using other processes or applications?
So that's the entire process going on there. That's from when somebody places an order in our e-commerce system, it flows automatically into, we have some custom software just to do integrations between the systems. A lot of that is just written in-house because most of it is just moving a little bit of data from here to here. It's acting as a middleman. So we use some Node.js applications for doing that. We use it to push the information from our e-commerce system, Shopify, into the configurator to run. The configurator runs through its entire process, and then it dumps it automatically into a directory or a queue that CADTALK reads, and then it kicks off automatically. So we don't have a middleware between those two. The CADTALK is the middleware, and it pushes it up into the ERP system. And then we do have a custom script that goes through the ERP system and looks for new items and orders that are entered in order to kick off the job packets that are going on. So there are a few little middleware applications that we've written in-house just to handle the back and forth data. But the entire process only takes 10 minutes.
Right. So if you wanted to duplicate what we have, you would need something like Infor CPQ, which is kind of the front end visualization for quoting. If you want to do e-commerce, you need an e-commerce on your website. In our case, it's Shopify. You need CADTALK, and then you need an ERP system. In our case, it's Infor's CSI or Clutch Industrial or Syteline product, depending on which month and what name they're calling it.
And not just to toot my own horn here a little bit, but I would also say that you should hire a software developer. Even if you're a manufacturing company, bring on a developer to help push some of your processes forward. You'd be surprised what we can automate doing different things.
I'll speak from this as one of the owners of our business. Ethan has paid for himself many times over. It's a good investment.
I didn't realize this was about to turn into an annual review.
Yeah, we'll get to that soon enough.
Sounds good. Well, the big takeaway I have is that automation in eliminating the mundane and the repeatable and the boring frees up a lot of room to do some really awesome, innovative work. And it seems like you guys have done a really awesome job at that. It's really cool to see. I'm personally just proud that we, CADTALK, get to be a part of it. So thank you for including us. Thank you for taking the time to be on this webinar to talk through this. But I think that's the big takeaway for me and for the folks who have attended, that taking the step toward a system that is repeatable, and then pushing that repeatable system to something that can do the work for you is a lot of work, as Ethan talked about at the beginning, but on the back end, it seems like it has been so worth it. So thank you guys so much. But maybe in the last minute that we have, Ethan, if you could leave people with, if they're stuck, they have that, they're in that garbage in, garbage out place, and they want to take the first step toward maybe a model-based enterprise or cleaning up their data or whatever that first step may, or whatever their goal is, what would you recommend as the first actionable step?
I would say don't look for one size fits all solution out there. Look for components that you can put into place, because you're building a puzzle. You're not trying to put together an entire drop-in solution. Everybody's business is going to be different, so every puzzle piece is going to be a little bit different. So look at the low-hanging fruit that you can take care of, look for an application or solution to take care of that, and just start putting them all together. So it's like for us going from the configurator to our ERP system, we needed a puzzle piece that fit in there. CADTALK was that puzzle piece. So we got that, we locked it in place. Then we went on to what is the next puzzle piece? What's the next integration that we have to do? So just look for the small puzzle pieces that you can put in place.
That's great. Well, we are up on time, and I want to make sure that we honor everyone's time. But I want to thank both of you, and thanks to everyone who attended for tuning in. And thanks, Ethan and Jonathan, for sharing your time and your knowledge and your experience. So thank you guys so much.
Thanks, Chris.
Thank you, everyone.